we propose a novel wearable skin stretch device for the upper limb called hBracelet. It consists of two main parts coupled with a linear actuator. The device is capable of providing distributed mechanotactile stimulation on the arm by controlling the tension and the distance of the two belts in contact with the skin. When the motors spin in opposite directions, the belt presses into the user's arm, while when they spin in the same direction, the belt applies a shear force to the skin. Moreover, the linear actuator exerts longitudinal cues on the arm by moving the two parts of the device. We present a qualitative experiment in a teleoperation scenario as a case study, to demonstrate the effectiveness of the proposed haptic interface, and to show how a human can take advantage of multiple haptic stimuli, provided at the same time and on the same body area. The possible behaviors of a robot are described by the finite state machine shown. The type of interaction depends on the current state. First of all, the hBracelet and the robot are initialized. Then, robot reaches the starting position and the hBracelet perform the calibration procedure. Now the connection between the robot and the hBracelet is enabled. The hBracelet applies a squeeze force related to the gripping force. When the robot lifts up the object, the hBracelet applies a translational force related to the object weight. Then the object is rotated and a shear force is applied on the human arm related to the torque of the robot. At the end of the experiment, the robot goes back to its starting position, and the belts of the hBracelet are released. 10 subjects participated in this qualitative study. Here one of them is shown. Since subjects do not see what is happening at the remote site, each transition between subsequent states strongly depends on what subjects perceive on their forearm, by means of the hBracelet interface. We decided to use this specific mapping strategy because, in our opinion, this way the actions of the hBracelet recall as much as possible the real interaction with the remote object, and subjects could intuitively understand what was happening at the remote site. After completing the test, the participants were asked to fill out a questionnaire, which sought to evaluate the value of transmitting robot state information to the user. The results show that the device is capable of informing about the forces acting at the remote site, hence improving the performance of the teleoperation system. Thank you for your attention.